In this video, I'm going to be instructing on problems similar to number 33 and 34 on the final exam review. I have made up similar problems, so they're not exactly the same. That way you can practice the ones on your review for extra practice. For both of these problems, they're very similar. We need to revisit some theorems that we've talked about in the past. The first one should have come up in Algebra 1, kind of, a little bit. We might not have talked about it formally in Algebra 1, and then also Algebra 2, both cases when you're solving quadratics to find their zeros. There's the irrational conjugate roots theorem. If a plus b root c is a zero, then its conjugate must also be a zero. This comes from basically the quadratic formula where you always have that plus minus square root. So we will always have a plus and a minus as our two roots. Then secondly, the one that we covered this year in one set of notes, I've lost it now, but if you go to the complex roots notes, I think it's around, I can't even remember. You'll see it as a title for the notes. We talked about conjugate pairs theorem, which is very similar. If a plus bi is a zero, then a minus bi must also be a zero. So for both of these problems, you're using those two theorems. They are asking you to write the equation of the polynomial that has the following zeros. It specifies lowest degree because technically you could make up as many zeros as you want and have a 100th degree polynomial if you wanted to get really crazy. So we're just looking for you to include these zeros and any other zeros that absolutely have to be there and stop at that. Make that the highest degree that you have. So for example, with number 33, the one that I've made up here, I'm saying that number 4 is a 0. That's just given. You don't find that yourself. That's given to you. And then 1 minus 5i is also a 0. So now your job is to write me the lowest degree polynomial that you can possibly make with those zeros. So ideally, you would know that you can make a factor tied to each of these zeros by just subtracting that 0 from x. That makes the factor that would give us the 0, 4. Then we also have another factor which gives us the second 0, x minus, and that's our second factor. However, even though that is a pretty low degree, it's only degree 2, we can't stop there because of the conjugate pairs theorem. 1 minus 5i must be paired up with 1 plus 5i as well. So that has to be another 0. There has to be at least 3. So I'm going to go ahead and write that one down as another factor. And now these are the 3 factors that absolutely have to be in this polynomial. There could be more if we wanted to make it a higher degree, but this is the lowest degree we can get, which is a degree 3. Now it is asking for the polynomial, so we will have to multiply, distribute, and simplify. So I'm going to go ahead and do that at this point. I like to start by multiplying the ones with the i's because that will start to cancel some stuff out and make it a little bit faster. Now remember, you will have to do a couple things. I actually just remembered I shouldn't start with the x squareds. I need to get rid of those parentheses inside, so I need to distribute the negative first, which you could have done in the same step. Then I'm going to basically FOIL, but with 3 terms. So you just want to make sure that you're multiplying every term in the second factor by each term in the first. So I start with my first term, multiply it, then go to the next one just to stay organized. That's what's really important here. Then I'm going to go on to the second term and multiply it to each of those. And now I'm going to go on to my third term and multiply it to each of those. Now, even though this is a lot of writing, there is a lot that should cancel out. Minus 25i squared. Okay, so that's our really long one. This is why I start here, because it's really long, but I get a lot of stuff that will cancel out, and that way I'm not distributing the x minus 4 to a bunch of stuff and making it look more ugly. So I'm going to simplify that second one as much as possible, combine any like terms. We've got an x and an x. We've got a plus 5ix and a minus. We've got a 5i and a negative 5i. And a 1 And then this right here is actually plus 25 because I squared is -1. So now I've got plus 26. Nice and pretty now that we've simplified. And now we can distribute again, basically the same process. Start with one term, distribute it, and then do the second. And then clean up by combining like terms, and you're done. And that is the polynomial of lowest degree 3 that has these 3 zeros. Now we do the exact same process over here with number 34. I'm actually going to need to grab more paper for this one. Alright, so number 34 is the same process, except we're not working with our complex roots, we're working with an irrational root. So again, we have those same zeros though, the ones that are given to us. I'm going to write those as factors right away, just so they're out of the way. X minus 3, x minus 2. Then we can turn this one into a factor as well. And lastly, we have to find its pair. All you're looking for is the opposite sign before the irrational number. So the last zero that has to be in this polynomial is 5 plus root 2. Now, of course, there could be other zeros. If we wanted a higher degree polynomial, it could include all 4 of these and some others. We would basically just be making up zeros at that point to make a polynomial as big as we want. But we want the lowest degree, and this one has to come with these 2. So 4 is the lowest possible degree that we can make. And again, I'm just going to make these into factors by subtracting from x. And now the last part is just to go ahead and multiply throughout. Again, I would start with the ones that are the ugliest looking ones just at the beginning. That way I can simplify them as much as possible before I start multiplying. And another tip that I have is when I have 4 factors, I like to break this up into 2 parts, multiply these 2, and then finally multiply everything together. So I'm going to go ahead and do that here. I'm actually going to do these first because they're going to take up the most space on my paper. So as usual, I start by distributing the negative, which you could have done all in one step. I just want to make sure everybody can see how I get these factors. And now I'm going to pick a term, distribute it through. Pick the next term, distribute it through. And pick the last term and distribute it through. Should have put that x first just so I make sure it's not inside the root. And that's the second factor. Now I'm going to go ahead and back up and do these 2 first. And now I'll finally clean this up before I start multiplying all the way across, just so it doesn't turn into a huge mess with a ton of different terms. So I've got my x squared, negative 5x and negative 5x, negative 2, root 2x and positive root 2x cancel out, 5 root 2 and negative 5 root 2 cancel out, and then 25 minus 2. Nice and pretty looking. And now we just distribute these through and we should have a degree 4 polynomial. And then lastly, combine like terms. $23, $50, and $6. And now my x's. Finally my constants. And there is our degree 4 polynomial, where if we factored it apart or graphed it, it should have these 4 zeros. All right, and then as usual, at the end of all my videos, if you have any follow-up questions, you can always leave a comment and I should see it, or you can email me back, and definitely let me know if there's any other problems you would like to see worked out. I would be happy to make a video right away. Thank you.